So I'm going to open today's video with a question for my viewers. Does it bother anyone how nonchalant Glenn is about finding 3 suppressors randomly? In this video, we're going to be discussing why your next suppressor should or shouldn't be a 3D printed flow-through suppressor. Today is December 23rd, 2025, which is 3 days away from the 2025 filing deadline for new ATF Form 4 applications, so I'm hoping you're watching before then so you can take action before the excrement display that is inevitable on January 1st, 2026. But even then, if you're just shopping around, I hope this video is equally informative to those new and experienced with silencers in general. The last decade of advancement in small arms technology has stayed relatively stagnant with firearm actions. Save for new Wildcat cartridges, each of which is the latest and greatest, and spiffy new furniture, there have been fundamentally few changes to the overall operating mechanisms and performance of firearms. In that time frame, I can count on a Velociraptor's talons how many NATO nations have adopted a new weapon platform that isn't an AR-18, 15, or 10 derivative. However, one area of small arms technology that has made massive leaps and continues to do so on a yearly basis is the manufacture and fundamental performance endpoint of silencer or suppressors. Up until the mid-2010s, almost every suppressor on the market followed the same design first patented by Hiram Maxim in 1909, a tube, baffle stack, and gas expansion chambers. Inside the suppressor, the gas volume expands, the pressure drops, and the muzzle blast turns from an explosion into a puff. It's still loud, especially with supersonic ammo, but significantly quieter, even if not completely silent. That's why the term suppressor is often semantically preferred by firearms enthusiasts, but silencer just rolls off the tongue better, and even manufacturers themselves use it conversationally. Save for some advancements in materials used, the mounting systems, and tubeless designs, aka welding mechanisms that allow for the baffles themselves to be the tube, losing their requisite housing tube for weight reduction, there have not been many deviations in silencer technology from the original mechanism of how the Maxim silencer worked. The advent of 3D printing technology has broken the mold of requiring silencer manufacturers to abide by the traditional subtractive manufacturing method of cutting away material to form the baffles. And no, this is not the 3D printing that makes polymer receivers or single-use PMAGs, but rather direct metal laser sintering, DMLS, where metal powder is fused at the darn near molecular level into its final composite structure. The complex geometries afforded by additive manufacturing leads to innovative performance endpoints that allow for flow paths that redirect gas instead of trapping it in entire suppressors printed as a single piece. Before we talk about the performance improvements afforded by 3D printing suppressors, why run a silencer on your weapon anyway? And even before that, let's pause 19 seconds for a quick hard-coded YouTube monetization algo disclaimer. I am not selling any firearms. All content in this video is for informational purposes only. I am not performing any modifications, legal or otherwise, and I encourage viewers to understand their state and federal laws. Still, even with hearing protection and a silencer, the reduction in rapport is noticeable to keep you focused and improve your situational awareness. The reduction in sound rapport to targets downrange is very understated. Morbidly enough, there is the obvious, real-world, tactical consideration of reducing your profile against targets that may shoot back. But another realistic use case in states that allow for them is hunting. Modern suppressors make the rapport from a bolt-action rifle scary quiet that no animals will scatter if they were shot at. If you actually do miss, the animal is unlikely to deviate from what it was doing, so you get another shot. If you're hunting with a partner and bag your animal, and there's a second animal, your partner gets a shot as well. Not only is the sound suppressed, but the flash reduction is as well. Silencers keep you on target better during low light shooting, so you don't have to contend with a strobe light being shown at you. To you and those beside you, suppressors perform amazing at reducing muzzle blast concussion. Even if you aren't running a muzzle brake, bare muzzle has plenty of concussive blasts from shooting indoors that can disorient you. Suppressors negate this. Because of the added weight of the suppressor, you also deal with less weapon recoil, which lessens the compounding fatigue effects that shooters feel and lead to longer and more productive training sessions. There are edge cases for suppressors where sometimes they can increase muzzle velocity and may even benefit barrel harmonics to improve mechanical accuracy, but it's very dependent on the host weapon. However, there are some drawbacks to running a suppressor. The most obvious is increasing weapon length and weight, leading to unfavorable handling for offhand shooting. Here's the problem with conventional Maxim-style suppressors. They trap gas. That increases dwell time, bolt speed, gas in your face, heat, parts wear, risk for malfunctions, and felt recoil if the weapon is overgassed. Some overgassing may help the reliability of weapons undergassed from the factory, aka anything imported or cloned by Sentry, but this is generally undesirable. And this is where our discussion of flow-through suppressor technology comes into place. Huxworks, formerly known as OSS, are the proprietors of flow-through suppression technology. Their 3D printed suppressors are known to affect baseline suppression back pressure and bolt speed by as little as 5%. Due to the additive manufacturing construction of their suppressors, they don't require conventional two-baffle architecture, but are often monocore. Huxworks has been incredibly successful in this endeavor and have won a contract to outfit the FBI HRT with their suppressors. The industry is trending in this direction of most new suppressors being of a low back pressure design, which almost all manufacturers, even those who've only ever done traditional designs, are now offering with low back pressure alternatives. My entry into the world of low back pressure silencers is the Hux Flow Range Titanium Monolithic 3D Printed Suppressor, which is threaded to accept adapters for industry standard mounting interfaces. It is rated for up to 338 LePou Magnum. Now, suppressing 338 LePou Magnum is going to be relative, aka you make only 5 adjacent lanes at the range HU instead of 10. But I'm very happy with its performance out of the calibers and barrel lengths I've shot it out of so far. My Griffin Armament M4 SDK sends a ridiculous amount of gas pressure into the action, so much so that after a suppressed shooting session, especially in the summer, I can smell the chemical reaction and gun lubricating solvents deep in my sinuses for the better part of 2 additional days. I have a Roscoe 11.5-inch barrel, and Roscoe barrels are notorious for running overgassed. After tapping out while trying different buffer and spring weights to have a comfortable shooting experience, I had to use a Black River Tactical custom gas tube with a downsized gas hole. Even then, I still get forward and erratic ejection using a conventional suppressor. But with my high flow-through Huxworks can, I can breathe. The ejection is much gentler and consistent. The difference in shooting experience is much more noticeable. So what's actually the catch? Why would anyone buy anything else at the moment? Well, this is going to get some pushback, but high flow-through silencers are just not that quiet, especially considering how much they cost. Now, you don't have to listen to me. I don't have enough tattoos, facial hair, or divorces for anyone in this industry to take me seriously. And it may not mean much coming from me anyway, because my flow range is probably the loudest Huxworks can because of the 40 caliber end cap. But regardless of how much money you throw at it, any silencer design is going to be a trade-off of these characteristics. Sound suppression for the shooter, sound suppression for others, your downrange signature, flash, back pressure, weight, durability, and serviceability. You cannot maximize all of those simultaneously. It outright defies physics to want a modular, lightweight, quiet, durable, low flash, and low back pressure suppressor. Even if you're wearing foam hearing protection, you can tell the difference while shooting a quiet and loud suppressor, because if you're shooting at a steel target, you can hear the ring of your target steel a lot better if it's a quiet suppressor. The honest to goodness truth is that a suppressor that prioritizes low back pressure isn't going to have nearly as good sound suppression as heard by the shooter, bystanders, and those downrange. There are very specific facets of sound performance that may allow for these high flow through suppressors to have shorter peak decibel impulse or resonance at certain ranges, leading to what many call, subjectively of course, a more pleasing tone. But if you do need very specialized equipment to quantify these differences outside of, I have ears and they work, how much does that matter for actual sound performance? The FBI aren't the only cool guys who have adopted high flow through suppressors. SOCOM has adopted the Surefire suppressors for their URGIs. The low back pressure was an important criteria during the requisition and procurement of these suppressors. The exact model, Huxworks Flow 5.56K and Surefire SOCOM RC2 are very popular for those who want the stuff that they use. However, military performance requirements and yours don't always need to run parallel to each other. It's absolutely fine to want a piece of equipment because it's exactly military. Not being militarily adopted is often a death knell for any new firearm action coming to market, just ask Desert Tech. For example, my M4SD Host is a near clone of the M4A1 Block 2. These high flow-through suppressors are requisitioned by a lot of units that either don't or simply won't perform action tuning on their host weapons. And beyond the obvious benefit of keeping large amounts of toxic gas out of your lungs, there's a more important requirement at play. the host weapon's operating system needs to remain largely unaffected. Flow-through suppressors accomplish that by minimizing changes to bolt speed, cyclic rate, and ejection behavior. Now, if you have the option to tune a host weapon, whether that's by reducing gas at the block or tube, changing buffer weights or springs, or some combination of the above, you can achieve reliable cycling and a much softer shooting experience with a conventional suppressor. But here's the reality. You rarely get the best of both worlds. Without the inherent reduction in back pressure that a flow-through suppressor provides, you're almost always making a compromise. The rifle will either be a little spicy when suppressed, or comfortable when suppressed but slightly undergassed when unsuppressed. You can tune around that, but you're tuning around a problem, not eliminating it. That said, a well-tuned action, especially one tuned at the gas port, can do an excellent job of minimizing blowback while remaining significantly quieter than a high flow-through suppressor. If you're willing to put in the time and accept some trade-offs, that path absolutely works. Some host weapons, however, even after a significant amount of tuning, can be miserable suppressor hosts for conventional suppressors. Enter the Legacy Scar. It, and many European rifles for that matter, start gassed so that even on the suppressed setting of the adjustable gas block, it will cycle most ammo. It takes a significant time and financial expenditure to get a comfortable suppressed shooting experience using a conventional silencer. Many high flow-through suppressors are just plug and play on these weapon platforms. And for some host weapons like my IWI Tavor, they do not have an aftermarket for action tuning and need a high flow-through suppressor to shoot suppressed. Look at how I'm getting ACOG scope bite on almost every shot. Look at my video that shows the Tavor gassed so hard with the suppressor that it knocked the charging handle off of its guide rod. Yeah. Do you see the sparking from my Hux flow range? That's not flash. That's the reaction of the unsintered material flowing against the microscopic roughness that is present in any 3D printed project. Plus, all suppressors have material burning in a secondary combustion. It's worse with titanium compared to other 3D printed materials like Inconel or even Haynes 2A2. The sparking should smooth out over time, but that's another hallmark of flow-through silencers. Downrange, sound signature, and flash. Even on non-titanium metals, 3D printed suppressors were notorious for being horrible at flash suppression. Newer NCAP designs have split the difference compared to conventional suppressors, but are still not quite there yet. For the FBI, their most common engagements are likely down a hallway, so downrange signature reduction is not relevant, but what if they do get into a shootout against the cartel at 300 yards? Again, I'm not FBI HRT, so I couldn't tell you why signature reduction isn't that big of a deal, but they have their reasons. So, what do we think regarding long-term durability? There's little reason to think that 3D printed suppressors won't hold up as well as their conventional silencer counterparts, as they are arguably stronger at the seams where the metal meets, because DMLS all but ensures there are no seams. The degradation that occurs is due to the same processes as how baffles erode in conventional suppressors, and conventional suppressors last minimally 50,000 rounds through semi-automatic use in non-short barreled rifles. I would expect 3D printed suppressors to get close to that number, maybe slightly less. What is more important for durability is the material. Titanium is not going to be as durable as Inconel or even stainless steel, and there are more firing schedule restrictions, but that is true of the material's non-3D printed counterparts too. What is actually relevant regarding long-term durability is if you ever need servicing due to damage to the suppressor. Many conventional silencer designs can be made to have a fully user modular build and are serviceable without jailbreaking. Many 3D printed suppressors cannot be repaired in a way that makes financial sense to the manufacturer or users. Yes, there are some traditional designs that may not be serviced or are difficult to service, like a tubeless design, and there are also some 3D printed designs that may be serviced. For example, the Huxworks Ventum uses a traditionally machined tube and end cap, but a 3D printed serviceable core. The Ventum was my first choice, but the dealer with a silencer shop kiosk didn't have them in stock. I fully believe with every fiber of my being that this will be the most common design in the future. Hybrid. With a traditional housing and 3D printed core, it preserves the best of both worlds. Fun fact, as of right now, 3D printing is not capable of the same manufacturing tolerances of traditional machining, so for applications where microtolerance and precise concentricity is required, like threading, it is still finished by traditional machining. 3D printing is doing excellent work at reducing weight because of the elimination of the tube-baffle relationship. My Hux Flow without the hub adapter weighs 8.8 ounces, which is interesting because one user reported 7.7 ounces. It's likely Huxworks made a style title update to baffle design without telling anyone. It happens all the time with 3D printing. And you see, that's amazing. There's no tooling or molds or dies to change out. You just feed the printer a different design. 3D printer technology is amazing and has opened up legitimate innovation in an industry obsessed with faster horses. But here's the bottom line. Flow-through suppressors are not universally better in every measurable / quantifiable metric. They're different. They prioritize shooter comfort, action reliability, and reduced blowback at the expense of absolute quiet, flash suppression, and sometimes serviceability. A flow-through can is not a windmill slam first pick for everyone. Heck, even the Marines are going with the notoriously gassy legacy design Knights Armament NTS SQD, which, coincidentally enough, my M4 SDK is based on. If you want the smoothest, cleanest shooting experience with minimal tuning, buy a flow-through suppressor. If you want the quietest possible rifle and are willing to tune your gun, stick with a traditional suppressor. There is no free lunch. The good news is that suppressor technology has never been better, and you're no longer locked into one compromise. A flow-through suppressor does not have to be your first choice by default. Choose one that fits your use case, not the one that just looks the coolest on Instagram. Thank you very much for watching this video all the way through. My name's David. Be sure to subscribe, leave a comment if you have anything to say, positive, negative, otherwise, or just leaving some feedback about my video. So here we go. Daddy's unboxing the suppressor, Miranda. Okay.